Yeah, thanks very much for coming to this talk and staying so late. So my name is Balázs, and what I'm going to talk about today is basically making meaningful contracts between your APIs and your clients. Very similar topic as before. The presentation will be much crappier, so sorry about that. So I hope you could hear what I said first, but I have a lot of stuff to go through, so I'm not going to repeat it. So what I'm going to talk about is very similar to the previous presentation, making meaningful contracts between APIs and the users of the given APIs. And for that, we're going to use Typescript, Openapi, which if you haven't heard of Openapi, then you're going to have a tough time today. But it's basically an open source standard that you can use to define your APIs. And Oats, which is something that I have been working on. So it's going to be a shameless plug all the way through. And to get started, first, I want to kind of go through as well what was the motivation, why did I start working on this. These days, as we have seen, most of the time, both on the front end and on the back end, you have strict typing. So on the back end, you have all the JVM languages for your pickings. You also have TypeScript, so Node.js, and you also have a plethora of other languages, all of them probably strictly typed. And on the front end, these days, most bigger projects already use TypeScript, so that's a pretty good start. But the issue, as we heard before, is that there is no link between them. So even if you are using a framework like, for example, Next.js, where the same language, basically the same folder contains both your backend and front-end code, and you can even reuse the same typings and the same libraries. Once you make an HTTP request, you are kind of on your own in terms of not mistyping on the URL, not mistyping a request method, or maybe interpreting wrong response. So whenever a public API changes with basically anything that you do, any of the users can break. It can break in a very spectacular fashion, like for example, your whole front end goes down, or it can break in a very subtle way, like one of your hidden features stops working because a field goes missing from a response. And in terms of the solutions, there was a very good solution before that we have seen, but I'm going to show you a few other solutions. One that you hear a lot is writing very good tests, but let's be honest, this never really happens. I have been in the industry for a while. I have never seen tests where this kind of stuff we were fully ready for. The second one is using another layer on top of the transport layer that you are using, so on top of HTTP or WebSockets. One of these can be, for example, GraphQL, which is a very good solution. And if you have never used GraphQL, then that's basically something that allows you to kind of in advance define the whole data exchange, what you can ask from the server and what you can expect in return. And it also defines how you can query this. And if you make mistakes, then you get immediate feedback. You also get pretty good tooling. Older alternatives like WSDL is something that people have used a lot for XML. But the fact is, at least in my experience, that most people just prefer HTTP and Rust, so the simplest stuff. And the question is, what can we do with Rust if we take that as a given? So we can still define what our endpoints expose and what do they expect using different tools. The most popular one of these is Openapi, which have been in the business for a while, formerly known as Swagger. People usually know it as such. And the problem with it is that on its own, it's not enough. It's kind of like a glorified wiki page if it's not being kept in sync with the actual code, if it's not part of your code base. You produce it once, and maybe your users look at it once, start developing based on it. But if it's not part of your code base, then it doesn't really make any sense to have it. And here comes the idea of generating code, which I completely understand is not everybody's cup of tea, because there is a lot of stigma around generated code. What happens if something changes and it overwrites something that you have written into generated code and stuff like that. But I'm going to show examples of the opposite. And with this approach, you basically have an Openapi document that can be an organic part of both your backend workflow and your client workflow, or whoever else is using the same same APIs. And in terms of generating code from OpenAPI, what are the options? I like to group it into two categories. There are the official OpenAPI code generators and third-party generators that what I'm going to talk about today falls into. And the question is, if there are already existing solutions, why did I make a new one? Because if there is 10 standards already out there, then we need an 11th one. And the answer for that is here. And before I start talking about this, I really don't mean to bash on anybody's open source contributions. They are all great. It's just basically my observations, what I have seen, and why I actually started making a new tool. So first, the official OpenAPI code generators that people usually start with. The issue with it is that if you are using it from any other language than a JVM language, then you are in trouble because it's a Java library, so you need to make Java part of your workflow. Second, it lacks customization, so it has some options, but mostly what you see is what you get. And in terms of extensibility, it also suffers from problems like, for example, generating based on string templates, which I think is a terrible option for generating type languages using string templates. And the last thing is the generated output. I never really was happy with what came out of any existing generators, but I really like the concept, and this is why I started working on a project like this. And what's the situation with third-party generators? Usually, if you are looking for a third-party generator in your language, then you can find it as well out there. But the other problems are still standing. It's difficult to customize if you need something that the generator doesn't have, and the lack of extensibility, and in some cases, the incompleteness of what it gives you is an easy deterrent for people usually. And here comes the shameless plug. This is my library, and this is what I'm going to demo today. I think the presentations will be shared, so if you are interested in, the links will be scattered around the presentation, and also they will be in the end. And what this does is it only does one language, and I hope it does this one language well. That language is Typescript that I know well. It, out of the box, generates you useful stuff, but has lots of customization. So the stuff that you generate with it, you can make it an organic part of your code base. And in terms of what this means, is that you can pick exactly what you want to generate. If you want static typings based on an OpenAPI document, you can do that. If you want just client-side code, a client SDK, you can do that. Or if you want just a server and the skeleton of a server, you can do that as well. Or you can do all of it. It has a clear API, so if you want to replace anything, because maybe reading your source OpenAPI document is not the easiest, like you have to go to 16 corporate proxies, then you can do that as well, but you don't have to without forking the project. And lastly, the generated output is written in such a way that it resembles handwritten code. I think that's something that most people have as a problem with the generated stuff, that it looks kind of like it was created by R2D2. But I try to do it in a way that it resembles code that looks like handwritten. And enough talk. I hope I can make this demo with one hand, but let's see. So I'm in the project here where I have a bunch of stuff already set up, and I think this is as big as it gets. Can you guys see the text?
Here, yeah.
So? Maybe one zoom?
There's free space in the front if you don't see it.
Free space where? We can use all the free space here. Hold on, I'm going to get the mouse. So if you have never seen OpenAPI, then this is going to be a very, very short crash course. OpenAPI is basically something that you can define either as JSON or YAML. And what OpenAPI is basically the structure of this document, how that should look like. So in our case, we have an OpenAPI document here, and I lost the microphone, sorry. I realized I have to speak louder to have the same volume. So we have an OpenAPI document here. It starts by basic garbage information of the version of it and a little bit of an info about it. And here comes the interesting part. In components, you can define the reusable parts of your OpenAPI document. Under schemas, reusable structures of JSON or something that's compatible with JSON can be defined. In this case, we have two models, two schemas, a book, which is an object type with a few fields, and some of those are required. Oh. And we also have an error type that we are going to use to express our errors, and that's going to be an object with a required message field. And here comes the more interesting part, the paths. These are basically the endpoints, the URLs that you can use, or that the API that kind of implements this OpenAPI document should expose. And here we have two paths. One is called books. And under this, we can hit this path with get or post. And under these objects, we have something that in OpenAPI language we call operations. And these, alongside with the outer information, so the path and the request method, define like a full request. What data does it need and what does it output? So what is the response? And here we have a request body. And this is how we define a request body. You basically define its content, if it's required or not. And then under its content, you define with what content type or MIME type, with what schema of data does it need. And then under responses, it defines what kind of responses can you expect. In this case, we have two or three types of responses. We have a 201 response. This is an operation where we create something, so add the new book. And with 201, you basically get back a response with a JSON content type, and the schema of this response is going to be a reference to our book schema that we defined previously in components. And under all the other responses, we get back basically an array of app errors. And this is the same for the rest of these guys. And I'm not even going to go through the rest because probably I'm going to run out of time otherwise. I'm rather going to show you what we can do from this. So the way you generate from this using my tool Oats, which is, by the way, Oats because OA as OpenAPI and TS. I felt very clever, but before the presentation, I checked out if it's accessible through Google, and there are like 3 other libraries with this name, so I'm not feeling that clever anymore. But anyways, this is how the configuration looks like. It's not dissimilar to what you would see in a Webpack configuration. So the philosophy was here, configuration as code. There is no CLI for this, so you run it yourself. And what we have here is basically the generator library that we import. And after that, we call a generate function on it. And here are the steps, what it takes. First, it reads your OpenAPI document somehow. You can use the file system, you can use the network, or you can do your own. Then you validate it, semantically validate it. Structural validation is taken care of by the reading step. Then it generates something. Here you specify how you want each generated artifact to be named and where do you want to put it on the disk. And lastly, specify here what exactly do you want to generate. And here I just went for a preset. Full stack preset is basically client and server because now you want to show both. But you can actually, I can't really type like this, but you can actually define your own generators that kind of hook into this infrastructure, and with fairly little code, it can generate whatever else you want from this. And lastly, it needs to be written back to the disk. And here, the only configuration I do is basically give it a formatter for which Oats ships with one that formats using Prettier. And I'm just using the project's already existing Prettier config. So all the generated stuff is formatted as such as well. So that's the configuration, and now let's run it. That's not good. I can't type with one hand. There we go. So what you see here is basically all the steps successfully completing. And here, each generated or generator package basically can define what kind of runtime dependencies does it have. Luckily, we have all of this installed already. Sorry, I didn't show the package.json before. Here we have all the runtime dependencies that are basically needed for the generated code to run. They are defined here, and they are also output when you generate. So in case you don't have these installed, then you can grab this npm command and do that now. And let's look at what has been generated. So the main idea was that the generated code should be as close as possible to as what you would do by hand, but obviously with this you don't miss stuff. And also what I wanted to do is that you never have to touch generated code. It's possible that if you use the generated code, when you regenerate, then you will get compile errors since it went out of date compared to what you have been using previously, but you never have to touch it. So let's look at the most important parts of this. Let's check out the client side first. So that's in this SDK file. And here, for the 3 different operations that we had in the Openapi document, we have a type that contains the 3 functions that can basically call these REST operations. And what you have here is basically tailored input and output for all of this. I'm going to go through this in more detail in a second, but these are basically just the information that this specific operation needs, and it outputs just what this specific operation is defining in the source Openapi document. Let's look at this one as we checked out this add book request in the document as well. Here, the only thing that we have is basically a request body and the MIME type that comes with it, so the content type, MIME type, whatever we're going to call it. And for the response, we have basically a union type where it lists all the different options that it can return. So either it can return a 201 with a book, that's the success, or it can return a 400 or a 500 respectively if it's a server or client error that happens. And since this is something that can be basically auto-magically generated as well, the actual implementation of this is also generated here. And this, I'm not really going to get into how it does its thing, as I'm going to run out of time otherwise. But this SDK implementation basically gives you an immediately instantiatable, if that's a word, version of the previous type. And the only thing that you need to provide for it is an adapter that you can also choose. I only provide a fetch-based adapter, and that's what we're going to see in a sec. And the other side, which I think is more interesting, as I don't really see much OpenAPI-based servers, but this is my attempt at that. And here you have basically roughly the same type, but here you see no implementation, as this is something that you need to implement. And here the logic is fairly similar. Here you receive a fully parsed version of what you defined in the Openapi document as your input, and you need to return a fully typed object, basically, containing all the stuff that is one of the responses that the client expects. And all the rest is taken care of you, so you basically need to implement how you want to move your data. And let's have a look at a sample implementation of this. Oh, give me a sec. Let's get rid of these errors. So what you have here is basically a class-based implementation of this API. And I'm using in-memory representation of these books, but obviously you could plug in whatever you want in here, database, another API, whatever you want. And then a simplest implementation is something like this. This is an API implementation that basically just returns all the books, all the data models that you have. And here you return a strictly typed object where basically everything works in harmony. So for example, if I break this harmony by changing this status code to 400, then you also get a compile error saying that this is not possible. As with the 200 or as with the 400 error code, you shouldn't return a book list, you should return an app error list. So let's go back to this version. And a more interesting part is how we handle input parameters. as input parameters need to be parsed. So it's not given if I define in an OpenAPI document that I need a JSON payload with a certain schema, then that's what the client is going to send. And the way this is done with the Oats generated stuff is basically what you get is your payload. This is true for all the parameters as well. So your payload wrapped in a try type. What this is, if you are coming from a functional language, for example, Scala, then you probably have seen something similar to this, like an either type, or maybe that even has a try type, I'm not really sure. And what that is a union type of either a success or a failure. If you have a success, that means that the data that you expected at that position, for example, the request body, has been successfully parsed. Otherwise, you get a failure with the issues that cause this problem. And in the issues, you have a severity, which in our case is always going to be an error, a path which can be helpful to figure out where exactly was the problem. So for example, if you have a nested payload, then this will be a JSON schema, and a message describing what exactly was the problem. And let's go back to here. And what we can do in application code, so this is something that we write by hand, is check if the given payload is a success. And if it is, then this can be, as this success function is a type guard. So once you are in an if expression or a conditional expression where this has been evaluated as true, then you can count on this body being what you would expect, so a book type. So here we can actually put together what we want, perform the operation that persistently, quote unquote, stores this data, and then return our response. And in the case it wasn't a success, it was a failure, so that is known as well by the compiler at this point. And at this point, you can turn that failure and the issues within it into your application-specific errors, which in our case is this app error type, which has a single message field. And here I'm basically just creating a string from this. So let's check out how this looks like in practice. So I'm just going to call this npm start, and I realized I missed a few steps before that. So it's nice that we have this class ready, but how do we actually create a server from this? And that's here. We are using Express for this, same as in the previous presentation, so lots of similarities there. And what we need to do is basically give it a body parser, same as what you would do normally, and then use two of these generated functions as well, that I also don't really have time to get into what they do. But one of them exposes for the rest of the routers in the application the API implementation. And
the undefined in the first in the agreement list first.
The undefined. Let's talk to me after. Talk to me after. I'm going to show you. Talk to me after. I'm going to show you. Okay. It's a long story. So you pass in the API implementation and the server adapter. This server adapter is responsible for bridging the generated code and your basically implementation of moving the data. And after that, you create a router here that basically creates a composite router that handles all the requests. So creates express routers that take care of the parameter parsing and calling the right API methods for you. Both of these are generated, but in case of emergency, you can override certain things on it. So if you are depending on this for, I don't know, a year, and something unexpected comes where I'm generating something that doesn't make sense for you, then you can override stuff in that as well. But I don't have time to show that, so I'm going to move on with this. And the final step is just as with any normal Express application, you listen on some port and start the server. And finally, I have an index.ts file. Now we are reaching the end of the server finally, where the only thing I'm doing is basically starting this server, so calling this start server function on a default port, and that's what we are seeing here. And let's check out how this works in practice. So here I have an API Explorer tool called Insomnia, and I loaded the Openapi document here as well. So we have the The endpoint's already listed here. When I call the method, the URL that retrieves all the books, then I get a list with a single entry in it. This matches our API implementation's hard-coded book implementation that you see here. And then if I call this post method with the same URL a few times, here is already a payload. Oh yeah, this is something I wanted to show you, but I forgot. So in this case, I'm missing a field. I'm missing the author field, which is something that should be on the book type. And if I do that, you see the mechanism that I talked about to have the errors or the issues with the request body. And we turn those issues into application-specific error messages, which in this case is basically an object with a message field. And if I add that back, oh, crap. So if I add that back, then the request actually goes through and we go with the proper 201 status code and we get back what we would expect. And now I think this is stuck and won't get away. It go away. Maybe if I switch tabs, no. Sorry, that's gonna stay there. So I'm sending this a few times and then let's check out our /books now. And congratulations, I managed to put items into an array, but through the network. So let's check out this from the client side, because this was the server part. Let's check out how you can instrument this Openapi enabled server based on generated code as well, but from the client side. So here, this is going to be much, much simpler. And this was the initial design goal that I had in mind. Here, what I do is basically instantiate the SDK implementation that is also fully generated. And I give it an adapter that does the request using the fetch API. And the only thing I configure here is the URL that it should hit, so the base URL of it. And the partial URL, so that you see the in terms of the /books and stuff like that, that's going to be at the end of these. And at this point, I can use this and all these strictly typed methods on it. This stuff is basically just starting the server that we have seen before all the tests and killing that server after it. And this terminator is not going to exterminate us. It's just because it's very difficult to shut down node servers without some external help. So I have a single test method where I demonstrate it. I didn't really want to do fancy front-end because it's not really meant for that. But here, the only thing that is happening is I'm calling this add book method on the SDK. And now I'm doing the opposite as what the server is doing, because I'm specifying the input data. And I want the output data, so the response. And this is also strictly typed. So if I were to do something like this, then you obviously see the TypeScript error messages. And after that, I need to check the status code. But here, this is also very strictly typed because we only see the options that are actually should be there based on the Openapi definition. And if the status code didn't match this, then we don't really want to continue with this. So I'm just going to throw. But after that, we know that the body is of book type and the rest of the stuff is as it should be. And I can simply make assertions on it. And after that, I can actually go ahead and query this freshly created book by using another SDK method, for which I provide it through the path, using a path parameter, this book ID, where I'm using the freshly created book's ID, and then checking again the status code, which defines what the response will be. If it's 200, then we know that the response.body will be a book. If it's not, then we know it's a list of errors. And so that I'm not bluffing, I'm actually going to run this. Oh, that's not why. And now you can see a single test passing. So sorry, this is not that impressive. There we go. So that's roughly about it. I still want to show you a few other things, and that is the documentation site, which is, I think I'm more proud of this than the whole project itself. Here you can actually read the documentation where you have detailed guide on what to do on the server side and what to do on the client side, and the stuff where you can read about how to extend it. That is coming as well, but a lot of stuff is already documented. This is also generated for you to basically copy-paste into your own project, and respecting what you set up here on the configuration UI, where I actually have configuration options. Look at this, so it's not just so simple. But anyways, based on what you put together here, the file that can actually run this is generated here, so you can copy-paste this if you want, and run generation locally. And there is also a package.json created that has all the Oats specific dependencies and a small script to run it. Oh yeah, and the last thing I wanted to show you is the repo. It's still here. But if you want to contribute, or if you want to check out what exactly is being worked on, then look at the issues. I'm currently the only guy who is working on it, so I'm making mental notes here on what to do next. And if you want to contribute either with checking it out, or maybe even opening an issue, or doing something on the code, then feel free to do so. And that's all I had. Thanks very much for listening. And if there are any questions, then go ahead.